Hello, welcome to Key Philosophies. We are back again, and this time on to Chapter 1 after many intros, but I find them valuable. And in this segment, we will be going over basic scientific concepts and knowledge, standing waves, oscillators and resonant systems, rhythm entrainment, coherency, capacitors, attenuation, free radicals, and then we will make time for etheric structures in the next video. Human etheric structures. All right. So, Chapter 1, Matrix 3, Basic Scientific Concepts and Knowledge. There are many basic concepts that you will need to understand in order to fully evaluate the data contained in this book. Understanding these concepts will also allow you to more effectively reach your conclusions after the book has been completed. We'll build on concepts as we go. Standing waves. If you stretch a string between 2 points and pluck the strings in the middle of its length, we see for a short time the outline of the string in the extreme positions of its movement, which form two symmetric arcs. If you pluck the string at the 1/4 mark of its length, you will see the following shape. The areas between the arc represent standing waves. We get such waves by plucking the string at distances that will divide the string into integral numbers. In the first figure above, the distance between the two ends of the string correspond to half a wave. In the second figure, the distance between the two ends of the string accommodates a full wavelength. In the second figure, the string has a point in the middle which is at rest. Such points of rest are called nodes. When the nodes along a string appear stationary while the rest of the string is vibrating, we call such behavior a standing wave. Oscillators and resonant systems. An oscillator can be described as anything which moves in a regular periodic manner, such as a vibrating string, a clock pendulum, or a weight hanging on a spring. Oscillators produce a sound as long as they alter their environment in a periodic manner. Suppose we tune 2 violins, then put one of them on a table and play the other one. If we watch carefully, we will see that the same string we are playing on the violin is the same string that vibrates in the violin on the table. This illustrates the concept of sympathetic resonance between the two vibrating strings. Oscillators. Such a system, made up of two tuned oscillators, is called a resonant system. Rhythm entrainment. Nature finds it more economical in terms of energy to have periodic events that are close enough in frequency to occur in phase or in step with each other. Such a phenomena can be seen to occur if we have two pendulum clocks on a wall. If we start one clock and then start the other, after a while the two pendulums will fall into step with one another. This phenomena is called rhythm entrainment. Coherency. When two sets of periodic functions or waves get in step with each other or become in phase with each other, we can say that they are coherent. The concept of coherence is important in understanding how living systems make use of electromagnetic signals. Nature uses highly coherent electromagnetic signals between and within living systems. The range of frequencies involved extends downward from the ultraviolet where radiation becomes ionizing. Maybe radiation becomes ionizing. I think that might be a typo. Through the sub-hertz ranges of seconds per cycle, the lowest frequency meaningful to the living system is the frequency corresponding to the reciprocal of its lifespan. Such fine-tuning of frequency through the lifespan of a living system carries with it the risk of sensitivity to and disruption by purposeful or otherwise environmental coherent electromagnetic fields, or, as we shall see later on in the book, disruption by virtue of higher order fields which lie outside the electromagnetic spectrum. I'll say also that that is the same thing that Raymond Rife was doing with his frequency machines when finding the mortal oscillatory rate of pathogens and then disrupting their ability to reproduce You can find videos on this on the internet as well. People doing similar things in current history. Oscillations and resonance happened in any structure. Oscillations and resonances happen in any structure. They become useful when they are interrupted in a coherent manner to convey information. This process is called modulation. Highly coherent oscillations can act as carriers for modulation, representing a control function for regulation, maintenance of homeostasis, control, or regulation in living systems. Capacitor. A capacitor is a device that stores an electrical potential or charge. This ability to store an electrical charge is capacitance. Attenuation. Attenuation refers to energy loss in an electromagnetic impulse. The further you get away from a radio station, for example, the more the signal is attenuated. Free radicals. Free radicals are not unconfined political activists. They are uncharged groups of atoms containing an unpaired electron that are very reactive chemically. Living systems need them to be able to use oxygen to get energy, but have devised ways of eliminating them when no longer required, since they may be produced in the organism by chemical and electrical processes. An excess of free radicals can give rise to unwanted chemical reactions in the body, which can lead to disease conditions. Stress, physical trauma, chemical toxicity, and infection can cause an increase in free radical production in the body and very often can overwhelm the antioxidant defenses of the body. The long-term consequences may include any inflammatory degenerative disease states, which are often associated with immune system suppression or immune dysregulation and carcinogenesis. Free radicals are particular atomic or molecular units having a simple unpaired electron in an outer energy level. The total of the electrons and odd numbers. The presence of free radicals are interactive with electromagnetic fields. Free radicals are only destructive to the organism when they get out of control. Then we have this. Let's rotate it. Here we go. Break it down a little bit. Physics of sound, music, frequency, and vibration, wave mechanics, wave motion, mathematics and geometry. We have images, figures. This one, figure 8-1, transverse wave, electromagnetic and light waves travel in this manner. Figure 2, longitudinal waves, sound waves travel in this manner. Also, scalar waves, which aren't really talked about because they were left out of the physics that are available to people. They were seen as as potentials and not real. We'll get into that later as we go on through this book. Matrix 3, standing waves, pipe organ tube. Harmonic vibration. Yeah, images just for studying. Thought process. Let's see what we got. Let's rotate back. Let's see. Amplitude. Coherent oscillations. Coherent, see how they're consistent there. Frequency equals cycles per second. Hertz. Cycles per second. Frequency. Hertz. The Maxwell conspiracy. Wavelength equals distance. Cycle. Random wave train. Discontinuities give incoherence. Incoherent discontinuities give modulation. Yeah, Yeah, I can relate to that, playing with synthesizers. Coherence and incoherence. Oscillations must start and stop. The shorter a burst of oscillation, the less coherent it is. Even if the frequency of two oscillations is the same, they may not be in phase. For any wave, its frequency multiplied by its wavelength gives the constant velocity with which it travels. The velocity only depends on the medium through which the wave is traveling. An exception is when a highly coherent is within highly coherent systems where the wavelength is constant and the velocity is proportional to the frequency. So you'll see projection of initial slope, decay, rise, response, constant. Just be familiar to anybody who works with music on a computer or with synthesizers. The quality of a resonant system is a ratio of the energy stored, energy lost per cycle. It expresses the sharpness of resonance and response rate. Resonance response rate. The more precise an oscillator is in frequency, the sharper its resonance. The longer it takes the oscillation to build up and decay, the sharpness of a resonance is called the quality, or Q. Yep, it's called Q, and is the reciprocal of fractional bandwidth or selectively obtained. All right. So I think that is all for now. Next, we'll be getting into human etheric structures. And maybe someday we'll get into using a Rife generator, because I have one. Well, thank you for joining me, and good night.